Hello and welcome to grade 11 physics. So we'll be starting with mechanics now. And so for our first lesson, I'll be looking into the intro for vectors, and I'll be working alongside Mr. Richard. This is Mr. MJ, and I'll be helping you through with physics. All right. So what we'll start with today is just an intro on vectors. And for each lesson, what I am looking to do, or to get you into the habit of doing, is to write down the objectives. So objectives just mean that what is it that I must know by the end of this lesson, okay? So for each lesson, I'm going to make sure that I have objectives. And even when you study, always make sure that you write down what you need to know by the end of the lesson so that you converge to that point. Right, so what do we need to know as an introduction to vectors? Right, we need to know how to define one, so using the correct terminology, because you get marks for choosing the correct definition. So we need to define what a vector is and to draw a vector, so simple structures and a bit more complicated structures. And by drawing vectors, another thing we can add here is that we have vectors in one dimension, 1D, and we also have vectors in 2D. So 1D and 2D vectors, it just means one dimension and 2 dimensions, and that's where this comes from. Okay, so the next thing that we're going to learn about is the two types of vectors, so explaining 1D and 2D. And then if time permits, we can also look at what we mean by components, because vectors have components. All right, so please pause the video, write down the objectives, and then let's start. All right, as an intro, is that to look at vectors, well, actually there's two things that we need to know. We need to know what a vector is and what a scalar is. So in this lesson, I will not focus on the scalar, I'll just focus on a vector. Right, so for definition, a vector is a physical quantity that has both magnitude and direction. So these words are very important, magnitude and direction. So what does magnitude tell us about? Well, magnitude just means that it has a specific size, or let's say it has a specific length. Okay, so it has a specific size, it's big or small, and has a specific length because we are drawing them on a page, so it could be a long line or a short line. Okay, so what magnitude tells us about is how big our vector is. Direction just tells us about where it's pointing. So where it's pointing or where it's going. So in just simple terms. So is it pointing left or right, up or down, northeast, southeast, and all that? Is it going up? Is it going down? Is it going left or is it going right? Okay, so the most important thing, or the three most important words or terms in this definition, is you must say it's a physical quantity, and you must say that it has a size or a magnitude and a direction. Okay, so that's how we're going to start this. So already we've covered the first objective. Let's look at the drawing vectors part and see how far we can get with that. So we represent vectors using an arrow. So a simple vector, so if I look at a diagram of a vector, so if I look at a simple vector, this is how I draw a vector. It has three main parts. Those three parts are a tail, it has a length, and it has an arrowhead which is pointing this way, and it specifies the direction. If it was pointing that way, it will be specifying the direction in that way. So a vector has simply a tail, and then if I look at this part, it has a size or a length, and we know that size and length are the same as magnitude. All right, so if this line was longer, it means my vector would have a bigger size, a bigger magnitude. Because it's a bit shorter, it means that it has smaller magnitude, yeah? And then this arrowhead is what tells me about direction. Okay, so a vector simply has a tail, it has a size, length, and it has an arrowhead. So this is an arrowhead. And what the arrowhead tells me about direction. What does the tail tell me about? Well, the tail tells me about the starting point. So this will be my start point. Sometimes it's called an origin. All right, so start point, origin, that's what the tail tells me. And then the length tells me about the magnitude, and then the arrowhead tells me about direction. So that's how you annotate a simple vector. Right, so now we know how to draw a simple vector. So you could point this way, you could point that way, you could point up, you could point down. So for instance, I can draw it this way. It has a tail, has a length, has an arrow. I can draw it that way. Same thing, I can draw it this way, like that. So excuse my accuracy with lines. As long as it has a tail, size, and arrowhead, it's complete. If you just draw a line like this is wrong. This is incorrect. It should never be like that. Okay, so now let's look at the types of vectors that we have. We have 2D and 1D. So I'll just draw 1D here, and I'll say 2D here. So 1D refers to what we call collinear vectors. Collinear just means they are on the same line. So I can have a vector like this. And then if you check your textbook, you find that they'll give you examples of vectors. So for instance, force, if you look at force, so before I explain this, I can just use force as an example. So if you look at force, force is defined as pull or push. Yeah, so if I have a block like that, so that's force. If I have a block like that, and then I pull it this way with the string, what you notice is that I will apply some force in that specific direction. So the force will have a magnitude. Looking at our definition, it will have a magnitude and it will have a specific direction, which is that way, which means force is a vector quantity. Okay. So if this is a force, all right, so let's say this is 20 newtons. Remember that newtons refers to the unit of force. That's 20 newtons. If I do this, what do you see? Well, you see that this is bigger than that, so it means this one should be bigger. So let's say that's 40 newtons. Okay, so that's essentially how it works. And what else do you notice is that for collinear vectors, they're only on the straight line, just straight line like that. They could also point that way. But because it's pointing the other way, this would mean that it will be minus, but let's not focus on that for now. It could also point that way, and that would be 20 that way. So these guys are pointing to the right, and these guys are pointing to the left. Okay, right, simple sense. For 2D, instead of them being collinear, I call them angled vectors. What do I mean by angled vectors? I mean that they are vectors that are drawn at an angle. Okay, so for instance, I can draw a vector like this, and then do this and say it's at an angle of theta, like that. Okay, so this is still a vector. So let's say that's like 20 newtons. It's a vector, but it's not straight collinear. It is at an angle. All right, so I can draw another one like that, and then say this is the angle. Let's say it's 10 newtons. Okay, so these ones in 2D are at an angle. So you'll see this question quite often. And then these ones are not at an angle, they're just flat like that. Okay, right, so that covers the two types of vectors. In your textbook, you might just see an example that says you have a vector that is 75 degrees north. You know that north is up, and then 75 degrees is just before you get to 90. So for instance, let's see if we can't do that example. So if I say I have 75 degrees as an angle, so theta is 75, sorry, and it's pointing north. How can I draw this? Well, you know from mathematics that you have Cartesian plane, this is 0, this is 90, right? So it means 75 would be somewhere here, and then I can draw my vector with my tail. How long is it? Let's say they said it's 10 newtons, and the angle, can use a protractor, that will be 75 degrees. Okay, and then that will be correct. That's how you will draw your vector. Right, so that's just for introduction on 2D vectors and 1D vectors. So, because of time, I'll just go to this quickly. The third point, which is to cover components. So components, we can only look at them when we look at 2D vectors. So how does that work? So I'll just use the Cartesian plane to try and explain it to you. Remember how a Cartesian plane is from mathematics. From maths, you know that a Cartesian plane is like this. In fact, what I noticed is that actually a Cartesian plane is made up of 4 vectors. So you have a vector that's pointing up north. You have a vector that's pointing up, I think this is east. Please correct me if I'm wrong. And this will be west, and this will be south. So you have 4 vectors in a Cartesian plane. You know this from maths, right? Where you put numbers here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, blah, 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 blah. Okay, so there are essentially 4 main vectors that I'm going to draw here, and I'll explain to you how the components are formed. Okay, so there are 4 main vectors that you can ever have. Here's the first one. I'll draw a vector here. I'll call it vector A. Notice that vector A is at an angle of theta. And then from here again, I'll draw another vector, vector B. Notice that vector B is also at an angle, let's say, of theta. I'll draw another vector, that is vector C. Notice that it's also at an angle, let's say it's theta again. And then I'll draw a fourth vector, vector D. Okay, and you notice that vector D is also at an angle. So essentially I have 4 vectors. What are these 4 vectors? Well, there's A, which is pointing that way, and then there's also B. I'll draw B here. Then there's also C. Make sure that I don't forget my tail. And there's also D. D. So these are the 4 main vectors that I've put here. Right. So when you look at the Cartesian plane, if I close everyone off, what you notice is that the way A is drawn, we have Y and we have X here. So when you have Y and X there, this Y and this X are called the X and Y components of vector A. So vector A has 2 components. This is the X component of vector A. This is the Y component of vector B. If you look at, vector A. If you look at this one and you do that, you notice how the components are. So this will be your Y component, that will be your X component. So if you see a vector like that, it means this is your Y component, this is your X component. Yeah? Let's go down here. If you close it like this, what do you notice? This is Y, this is X. So Y, X. Okay, and the last one, you close everyone off. Notice this is your Y and this is your X. Okay, so this is X and this is Y. Right, so it seems a bit complicated. Sorry, my light went off there. It seems a bit complicated, but it's not. Okay, so whenever you see a vector drawn like this, it means it'll have these types of Y and X components. If it's drawn like that, it'll have this type. If it's drawn like this, it'll have this type. If it's drawn like that, it'll have this type. Okay, so that's just these 3 objectives covered in a nutshell. Okay, so please comment on the comment section if you have any questions or anything that is unclear, either on 1D or 2D. It's just an introduction, and then when we look at more questions, then we can see how it is applicable. All right, have a great day. God bless you.